So in the previous lesson, we stumbled upon an issue. Sometimes when we were solving multi-step equations with decimals, we ended up with a repeating decimal. And that was an issue because if we checked our work, it would have made things a little bit difficult to evaluate. So instead, I'm going to show you another method to how we convert our final answer to a fraction without having to know how to convert repeating decimals to fractions. So the very first step here is, just like in our notes, we're going to check, can we distribute? In this case, I'm going to say yes, I can distribute, so I'm going to go ahead and do that. I'm going to distribute 1 and 2 tenths to 4x, which is going to give me 4 and 8 tenths x. Then I'll distribute 1 and 2 tenths to a positive 3, which is a positive 3 and 6 tenths. I'm going to go ahead and bring down the next few terms. So I'm just going to put plus 2 and 7 tenths x equals 6 and 6 tenths. Now the next step would be, can I combine like terms? In this case, I can. I'm going to go ahead and combine a 4 and 8 tenths x with a positive 2 and 7 tenths x. I'm going to go ahead and do side work to figure out what that is. So do 4 and 8 tenths, add that to 2 and 7 tenths. Notice I'm lining up my decimals. 8 plus 7 is 15, carry the 1. It's a 7, bring down that decimal. So here I have 7 and 5 tenths x. And again, I'm going to bring down the terms I didn't use. So I'm going to put plus 3 and 6 tenths equals 6 and 6 tenths. Now I went ahead and distributed. I combined like terms. So the next step would be to eliminate your constant. So in this case, you'll notice there's two constants. On the left-hand side, we have 3 and 6 tenths. And on the right-hand side, we have 6 and 6 tenths. So which one am I going to be focused on? Well, if you're ever not sure, please remind yourself that your goal is trying to isolate the variable. So in this case, my focus is strictly on the left-hand side. So what you're going to want to do is eliminate the constant on the left. And I'm going to do that by subtracting 3 and 6 tenths from both sides. Here, these are additive inverses. A positive and a negative will give you 0. So now we're left with 7 and 5 tenths x equals, here, let's do some side work. We have 6 and 6 tenths minus 3 and 6 tenths. 6 minus 6 is 0. 6 minus 3 is 3. So it's 3 and 0 tenths. Do I really need this 0? I would say no. So I'm just going to go ahead and write it as 7 and 5 tenths x equals 3. Now the very last step would then be to get rid of your coefficient. Well, just a quick reminder, a coefficient is the number in front of the variable. So here we have 7 and 5 tenths x, which means 7 and 5 tenths times x. So the inverse operation would then be to divide by both sides with 7 and 5 tenths. So here, 7 and 5 tenths divided by 7 and 5 tenths is just 1. 1 times x is x, leaving me with x equals 3 over 7.5. So notice here, not only do we have a fraction, but we also have a decimal. So remember, I told you that instead of writing our answers as a decimal, just in case we end up with repeating decimal, it's going to be better to write your answer as a fraction. So here, I'm going to show you how we can do that. So right now, the only thing keeping this fraction from being both a fraction and decimal is this decimal right here. So what I could do is make it a whole number. And the way that I would do that is to multiply by 10. If I multiply the denominator by 10, I'm going to have to multiply the numerator by 10. Because again, 10 over 10 is just basically multiplying by a large 1. And multiplying by 1 doesn't change the value at all. So here, now I'm going to have 3 times 10, which is 30. 7 and 5 tenths times 10, essentially you're making the number larger by 1 decimal place, so it's going to become 75. Now last but not least, we got to make sure our answers are reduced. Always make sure your answer is reduced. So here, I'm going to go ahead and see that I can definitely divide by 5, so let's do that. Divide by 5. Leaving me with 6 over 15. However, if you take a close look, this is still not reduced. I can go ahead and reduce once more. I've noticed I can divide both terms by 3, so I'm going to go ahead and divide by 3. And my final answer would then be x equals 2/5. So now, even though our original equation started as a decimal, I still was able to convert my final answer to a fraction. This is going to help you a lot, especially with checking your work. So another thing I wanted to mention is you're going to notice sometimes once you reduce, you might notice that you have to reduce again. So don't always assume that after you reduce once that your answer is complete. So here, what you could have done is realize that instead of dividing by 5 and then 3, you could have essentially divided both terms by 15, which would have led you straight to 2/5. Okay, so now we're going to go ahead and just move on to our next example. Okay, so moving on to our second example. This particular example was chosen for a reason because in the previous quiz, a lot of my students had a misconception when it came to the distributive property. So I want to show you that in this particular problem. So going through the original steps, ask yourself, can you distribute? In this case, the answer is yes. Real quick though, was something that a lot of my students did in the previous quiz was they decided to combine these terms first and then distribute afterwards. Why is this incorrect? Well, according to the order of operations, you're supposed to multiply before you add. So this is, you're doing the operations out of order. So this would be incorrect. So again, you would go back to your notes and always distribute before you add. So here I'm going to go ahead and distribute 1 5/10 times 3x, which is going to give me 4 5/10 x. Then I'm going to distribute 1 5/10 to a positive 4, which is going to give me positive 6. Now all I have to do is bring every other term down that wasn't used, so negative 3 6/10. And then I'm going to add 4x equals negative 12. So I went ahead and distributed. Next step would be to combine like terms. Here, I can combine the variables as well as the constant. So first, let's take care of the variables because that's what we would normally write first. I'm going to combine a positive 4 5/10 x with a positive 4x, which is going to leave me with 8.5 x. Now I can also go ahead and combine my constant. I'm going to go ahead and combine a negative 3 6/10 with a positive 6. I'm going to go ahead and do that off to the side. Here I'm going to have 6. Notice I write the decimal afterwards. Kind of, if you need to, think about how you would write $6. I'm going to subtract 3 6/10. Here, these zeros were not necessary, but just again to show you where the decimal is. That's why I wrote it there. We have a 0 here. We're going to borrow. 10 minus 6 is 4. 5 minus 3 is 2. So again, the 0 is not necessary. So I'm going to go ahead and write 8 5/10 x equals, not equals, sorry, plus 2 4/10 because it is positive equals negative 12. So I went ahead and distributed. I went ahead and combined like terms. So the next step would be to get rid of your constant. So I'm going to go ahead and subtract 2 4/10 from both sides. This is going to give me 0, leaving me with 8 5/10 x equals, here I know for sure it's going to be negative. I'm going to do some side work. Since they're both negatives, I'm going to combine them together. Notice I need to make sure I line up my decimals. So 0 plus 4 is 4, 2 plus 2 is 4, 1 plus nothing is 1. So that's going to equal negative 14 4/10. Now here, the very last step would be to get rid of our coefficient. This here is 8 5/10 x, which means 8 5/10 times x. So I'm going to go ahead and do the inverse, which is to divide both sides by 8 5/10. Here, 8 5/10 divided by 8 5/10 is just 1. 1 times x is x. Now here, again, we could do side work and do the division, but that's going to take you a little bit more time. Instead, what we can do is go ahead and convert this into a fraction. How? By simply getting rid of the decimals. So what I'm going to do is notice that in order to make these numbers a whole number, I'm going to at least have to move my decimal once over to the right. So I'm going to go ahead and multiply by 10 to both the numerator and denominator. And once again, 10 over 10 is just 1. Multiplying a big 1 doesn't change its value at all. So I would get an answer of, well, let's see, moving my decimal once over to the right. It's going to leave it here. Once to the right, it's going to leave it here. So I'm left with negative 144 over 85. Now all I have to do is check to see if I can reduce. In this case, I can't. So I'm going to go ahead and say that my final answer is x equals negative 144 over 85. So once again, I started with the decimal, but I went ahead and converted my final answer as a fraction. And once more, this is going to be helpful so that when you do check your work, you're not going to have to worry about plugging in values that are repeating decimals.